Welcome back. This is video 2 of the congruency sequence. Trust you enjoyed the first one, and we'll continue looking at how to prove congruency in this video. In the booklet I shared with you, you will find a few examples where you must cut and see whether these shapes are congruent to each other. Look at the following, whether they are congruent to each other and whether they are not. Right, let's see if these shapes are congruent to each other. This side is parallel to that one. We have it here also. Have this side equal to that side. That's sorted. Then we have an angle that is equal. But notice that this one is an obtuse angle and that one is an acute angle. So even if he is flipped over, that this side be on that side and this side be on that side, they won't be congruent. When we look at these shapes, we've got two sets of adjacent sides being equal to each other in the form of a kite. We have one included angle between the two sides that is marked the same as this one. So this will be congruent to that. Quickly have a look at 2.3 here. Tell me if you think that they are congruent or not. Definitely cannot be congruent because here I'm having the properties of a square. Here I potentially have a rectangle. And here probably a rhombus because there's no 90-degree indicator. So none of these shapes are congruent to each other. When we talk about congruent figures, they must be identical in all respects. All the corresponding angles and sides must be equal to each other. Meaning an angle with a side opposite it, if that side is 12 and the angle is 30, then in another triangle the angle must be 30 and the corresponding side that is opposite it must also be 12 in that regard. Two triangles are congruent when all three sides are equal, or two sides with an included angle. If two angles and a side is equal, when the 90 degrees, the hypotenuse and another side is equal. This particular case we normally call RHS, the right angle, the hypotenuse and the side. Familiar with right hand side? So very similar. We cannot say angle, 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 because if there need to be one side a length to justify that the triangles will be congruent to each other. Because if the angles are the same, the one triangle could be an enlargement or a reduction of the other shape. I must say something here. If two figures are congruent, they are similar as well. But if two figures are similar, they are not always congruent as well. Okay? So figures can be congruent and similar, but not necessarily similar and congruent. For each one of the following, you can hit pause and study the figures and check whether they are congruent. I hope you have your answer. Look at number 2. I trust you have your answer. Number 3 and number 4. Hope you have your answers. At 1.6, you can press pause. I hope you have your answer. Just a reminder, in parallel lines, we find that there is corresponding angles forming a F and alternate angles forming a Z. So when I have angles between parallel lines or around parallel lines, I must still observe those properties as well. We will look now at how to write out a proof of congruency. Firstly, there's a basic scheme of how we write things. Firstly, when we write out congruency, we will show that the one triangle and the other triangles we write in triangles ABC and DEF, then we'll write the first thing that is the same. For example, AC is equal to DF. Number 2, if there's a reason, in this case it was given. Number 2, we will say DE is AB is equal to DE. So everything about triangle ABC will be listed here. Everything of triangle DEF will be listed on this side. So I will write number 2, AB is equal to DE, and I will write it was given. Then at number 3, I will state that BC is equal to EF, and that reason will also be given. Now I will write in the same sequence as what I've proven that this triangle is congruent to this triangle. So we started with AC, but let's call it triangle CAB. So in the same breath we will say the same sequence as DEF, DE is congruent to each other. And my reason for my congruency in this case would be side, side, side. That is an approved method of proving congruence. Notice in this instance I've changed this one around with that one. So now I will say that if I say triangle CAB is congruent to this triangle, I will start with the same side that is equal, then the next side that is equal to the finishing point on the other side. So I will say CAB is congruent to EDF. So the same sides that follow each other. So, and my state of congruency will be side, side, side. We have mentioned that everything for triangle ABC was listed on this side, and everything for triangle DEF was listed on this side. Once the triangles are congruent, the remaining corresponding parts are equal as well. What does this mean? That angle there, angle D, will be the same size as angle A. Angle C, which is between the 1 and the 3, will be the same as angle E. So C will be equal to E, and angle B, which is between 2 and 3, will be equal to angle F, which is also between 2 and 3. These are the things that I need to know. If we did not list all the sides and we listed angles in between, the remaining sides will also be equal to each other. When we speak of corresponding parts, we mean parts which are in the same position. We showed in the sketch the position of the different parts. There's 3 movements to see if one triangle fits exactly onto another. We can slide it along, we can flip it over, or we can swing it around, meaning rotating. So, translate, flip, or rotate. Those are the 3 terms that we will be using. Let's look at a few examples. How could they possibly ask you this? They say in this figure, AB is equal to AC. So I first locate AB, and I locate AC, and I mark that they are equal to each other. D is the midpoint of BC, of that line. So that means this part here is the same length as that part there. Now they ask us, is angle BAD, meaning that angle over there, equal to DAC, which means this angle over here. Now they say write down your argument. So, I need to prove that triangle BAD is congruent to triangle CAD. So let's look at the information that we have. We firstly list that BD is equal to DC, and we will say it is given. We will say AB is equal to AC, and that was also given. Then we have a third side which is common in both triangles, that is the same length. So we will list that AD is common. So that makes triangle ABD congruent to triangle ACD. And notice the sequence. The side with the 2 lines, the side with the 3 lines, the side with the 2 lines first, then the 3 lines. So my sequence of listing must be in the same sequence. If I had said triangle DAB, I would have had to say triangle DAC. If I started with DBA, I had to start on this side also DCA. So your routine must be the same. So from the congruency, we notice then, because this triangle is exactly the same size as that triangle, the angle between the sides 2 and 3 will be equal, and that makes this angle also equal to each other. You can try to do the next one. You can press pause and try it on your own. To conclude, I've listed again the information about parallel lines, corresponding angles, alternate angles, and supplementary and co-interior angles. I've listed also what is to be done when a triangle has equal sides. When you work with a straight line, when you work with a triangle, speak about vertically opposite angles that are equal. Quadrilateral, we talk about the sum of the angles being 360 degrees. Angles around a point add up to 360. And a pentagon, the sum of the angles is 540. An equilateral triangle, all the angles are 60 degrees. Now, in the booklet that I've provided, I've asked that you do the following sums. You can press pause and do them at your own leisure. Don't have to rush. Skip to 1, 2, 3, 4. Then we go to number 2. Here, this one is quite interesting. Here we have to apply our information about parallel lines. Firstly, this angle and that angle on the same side of the transversal line, but between the two parallel lines, so they are co-interior angles. We know that co-interior angles add up to 180 degrees. So 2x plus 3x is 5x. So 5x is equal to 180. Then I solve for x. 5 multiply with what number will give me 180 degrees. So we say 180 degrees divide by 5, and we get an answer of 36 degrees. So now we have x is 36. So 2x is 36 times 2. So this is 72 degrees. And in a parallelogram, opposite angles are equal. So if this is 72, that one must be 72. We test more properties of quadrilaterals. Also with parallel lines, what do we know? It's 2.3, 2.4. I really appreciate the fact that you managed to watch this video. If you liked it, tell your friends. If you loved it, share it with everyone. Thank you. We'll see you in the next round.